Hey everyone, this is Mike Shaw with Planit for Photographers, and in this video we're going to show you how to use the depth of field tool. Again, let's start by hiding the ephemeris pages, since the depth of field tool doesn't need the ephemeris information and we can maximize our screen. Tap the mode button down here. You'll see 6 tools represented by these 6 buttons horizontally. The 4th button over is the depth of field tool. Tap it to select it like this. Let's now see how to use this tool. First, let's set the camera location to the east end of the famous Stone Arch Bridge in Minneapolis, Minnesota. Next, we'll set the scene location to one of the buildings in the Minneapolis skyline. By default, we've set the camera to focus on the scene location as well, as you'll see in a moment. Now, you can see this green fan pointing to the building, and along the top you can see the key camera settings. The green fan represents the camera's field of view. The aperture is f8, the focal length is 50 millimeters, and the subject focus distance is 0.77 miles. Now, just to be clear, what we're calling the subject focus distance is the distance between your camera and the subject on which you're focused. It's completely different than the focal length, which is a characteristic of your lens. So the subject focus distance can be anywhere from really a few inches for a macro lens all the way out to infinity. Now, back to our example. How did Planit determine the distance of 0.77 miles? Well, let's tap it to see our options. As you can see, there's 3 of them as follows. Number 1, focus at some fixed distance that you enter. 2, the default, which is what we have, focus at the scene distance. And number 3, focus at the hyperfocal distance. Since the default is to focus on the scene location, or in other words, our subject, which is what we did, this distance means that the building in the city skyline is 0.77 miles away from the camera location at the east end of the Stone Arch Bridge. Now to the main event, the depth of field results. These are represented by these 2 values right here, around 34 feet and infinity. Now what these 2 numbers mean is as follows. First, that the near focus distance, or the distance between your camera and the closest thing to it that's in focus, is 34 feet. The far focus distance, or the distance from your camera to the furthest away object that is still in focus, is infinity, which means everything. Great, but what's a good way to see what these values mean? In other words, how far away is 34 feet? Well, let's zoom in on the map, like this, and check out this curved black line. This black line shows you on the map exactly where the near focus boundary is, or the line between objects that are in focus and objects that aren't. To be clear, anything between the black line and the camera is not in focus. Anything beyond the black line and the far focus distance, which in this case is infinity, is in focus. In other words, the black line is 34 feet away. So great, what we've just seen is the basic outline of how we use the depth of field tool. But let's explore a few more things that you'll be interested in depth. First of all, what happens if we change the aperture? You already know that the depth of field is controlled by the aperture, so let's see what happens. Now first note that at an aperture, or f-stop of f8, we have a near focus distance of 34 feet, which is what we just saw. So now let's tap on the aperture value to change it to a smaller aperture, let's say f32. And now you can see that the near focus distance has moved much closer to the camera. Instead of 34 feet away, now it's only 8.5 feet. The far focus distance stays the same as infinity, so you could say that we've increased our depth of field by decreasing the aperture. But on the other hand, what happens if we increase our aperture to f2.8? Now the near distance increases all the way out to 95 feet. If we go 2 stops more to f1.4, it's over 180 feet away. So we can conclude that the larger the aperture, the smaller the depth of field. Let's now reset the aperture back to f8. And now let's explore the effect of lens focal length on the depth of field. So we'll start by changing the focal length to 150 millimeters. Look here, the near focus distance has increased greatly. It's all the way out at over 280 feet. But now if we go back to a wide focal length of 14 millimeters, this brings the near focus distance all the way into almost just short of 3 feet. What a huge difference. So you can see the wider the focal length of your lens, the larger the depth of field. And of course, that's exactly what we observe in practice. Now, for what we just saw, we were focusing directly on our subject, which is the Minneapolis city skyline. But we have options. You can choose to set a different focus distance method. Let's go ahead and tap on the focus distance number to see what they are. And look down here. This bottom one is the hyperfocal distance. Pretty fancy term, huh? Well, actually, the hyperfocal distance is surprisingly easy to understand. It's just the distance to the closest subject you can focus on and still have an infinite depth of field. And that's it. In other words, if you focus on anything closer than the hyperfocal distance away, then the far focus distance will no longer be infinity and you'll be stuck with a finite depth of field. And that's really all there is to it. So if you want to learn more about it, just Google it and you'll find loads of helpful descriptions and examples. But just the key thing to always remember is when you're focused at the hyperfocal distance, you always get the maximum possible depth of field. So if we tap on it like this, you can see the hyperfocal distance here, which is only 2.7 feet for a 14 millimeter lens. And you can also see how the near focus distance is much closer, just short of 1.5 feet. Thus, you can conclude that we've increased the depth of field significantly. And this is important, and it bears repeating. When we choose to set our focus at the hyperfocal distance, even though we are no longer focused directly on the Minneapolis city skyline, but instead we're focused on a spot only 2.7 feet out in front of our camera, the city skyline is still in focus. I know that sounds almost unbelievable, but it's true. And that's the benefit of using the hyperfocal distance. All right, let's keep going. Now, you can also tap up here to customize the information to display. The first option is the near and far focus distances of the depth of field. The second one is the depth of field in length units. The third is the distance before and after. And the fourth is the hyperfocal distance. So you can choose here what combination you prefer and set it just like that. Okay, so now let's go through a demonstration with a model where you can see what happens when you make a few adjustments. First, let's move the camera location a few steps back, and we'll reset our focusing method to focus on the scene location. This way, you can have a person standing on the bridge right at the tree line. Let's add a marker for their position, and we'll set that as the scene location like this. Now, instead of focusing on the city skyline, I'm focused on the model, again represented by this marker and scene location tab. So again, we'll use our 50 millimeter standard lens with an f2.8 aperture. And here are the results. For a model standing here with a focus distance of about 50 feet, a city skyline as the background, and a 50 millimeter lens with an f2.8 aperture, we have a near distance of just over 30 feet and a far focus distance of just over 100 feet. And you can see all these distances on the map. The thicker green line is the subject focus distance for a model standing here with a focus distance of about 50 feet. The thin green line is the far distance. And the inner boundary line here represents the near distance. In other words, everything between these two boundaries is in focus. Notably, the Minneapolis skyline isn't. In fact, if we were to use these settings, the skyline would be way outside the depth of field and be totally blurry. In fact, it might not even be recognizable as a city skyline. Now, the thick dark red line here is the hyperfocal distance. How far away is it? Well, we'll tap here to see. And you can see it right here. It's just short of 100 feet. If you now choose to focus on this hyperfocal distance, can we get the city's skyline in the depth of field? Well, of course. I mean, remember, anytime you focus at the hyperfocal distance, the depth of field is infinity. This means that everything out to the horizon will be in focus. In this case of hyperfocal focusing, the near distance is here, right around 50 feet, right just there. The model is here, which is just okay. And we get the skyline in focus as well. Now, let's suppose that the model moved forward to this location. Will it still work? No, as the model's outside the depth of field, so the model would not be in focus. So as long as the model is in the area beyond the first green line, everything will be fine and in focus. The model and the city skyline will both be in focus. Now, let's say that you don't want to focus on the hyperfocal length, but you just want to focus exactly on the model to get a sharper image. How do we choose the right aperture to make sure the city skyline is focused as well? We don't want to change the focal length. 50 millimeters is the one we want to use. It's so easy. We just carefully change apertures like this while we monitor the far focus distance until it becomes infinity right up here. So right here, when the aperture is this, the far distance is infinite. This means we can use these settings and get both the model and skyline in focus, only if that's what you want, of course. Well, that's it for the depth of field. It's not that complicated, but this is the first time that we show everything on the map to make everything more visual. In the real world usage, we often combine it with other features in the app to determine beforehand what's the best settings to use. For example, when we shoot a full moon with a model using a long telephoto lens, we can use this tool, the depth of field tool, to figure out exactly what aperture to use to get both the moon and the model in focus in a single shot. So until next time, this is Mike Shaw saying thanks for watching and best of luck planning with Planit.